So let's look at the example and we can see here exactly how this works. So just to again recap the general idea, here is that we have this instruction. So we have an add here and two registers. So this is what we have in basically assembly. So this is what you type in Mars. So that's the code that you want to read. On the memory, the processor doesn't understand this just like that. So the processor works with basically bits only. It works with zeros and one. So the whole story again of this chapter is that we are converting this instruction to series of zeros and one. And this might remind you actually of the movie like Matrix, how everything is basically like 0 and 1, and it shows like with the kind of special effects. So this is the idea, that this is something that we type and we read, but actually the processor, what the processor understands and what the processor runs is these zeros and ones. So let's continue and look at how this is actually converted. So we saw that the pattern, we already looked at this pattern. So all we have to do here is to basically fill in each part of this pattern to get to this final number. So for each instruction, we said that the opcode or the operation code and this extended operation code depends exactly on the instruction. So there is a table that is on the slides that you can look up. So here we are dealing with the add, and if you look on this table, it gives you that pattern. It's the same pattern that we have here, but the opcode and the extended opcodes are basically filled. So if you look, the first 6 bits here are zeros, and as we said, all of the R format, they are all zeros. So these 6 bits are all zeros. So here we're gonna get 6 zeros. And basically this is like the answer that we have down here. So we see that we have that 0 on here. So this 6. And then on the last, so we had 11 bits. So we're gonna look at this. So that's 4, 8, 9, 10, 11. So from here. So these 11 bits is the extended opcode. And if we look at through all of these, there is only this one that has this pattern. So the bit on, basically it's all 0 except, so this is the 5th and the 6th bit. If you start from 1, 2, 3, 4, 5, 6. So that is the only one that is 1 and the rest are 0. And if you look, that is the only one that has this. So that's how the processor knows that you're dealing with the add. So, and then you see here that down here or here, we actually put that 11 bits. So that's for extended opcode. So now we are done with this last box and this other box. So these two are done. And what is remaining is these 3. So how do we do this? So it's actually very simple. If you remember, we said that each register that we are working with has a number. So for example, we said S0 is, I'm just saying like maybe like number 16, or S1 is number 17. So each actually have a number and they're indexed from 0. So all you need to do, you need to just convert that number to a binary number. So for example, here this register 23, maybe if you look at MIPS, that would be, I don't know, like T0. So if you see a T0, you look up to the table to see what is T0, what is the number for T0, and you see, let's say it's 23. So then you just have to convert 23 to a binary number. And this is RD, so RD is going to this block. So it's gonna be basically on this last one. And if you convert 23, so that's the same as here. If you convert 23, you see you're gonna get this number. And we can convert this back quickly. So this is basically 2 to the power of 0, 1, 2, 3, 4. That is 16 plus 4 and 2. So that's 22 and then 1, 23. So very quickly you can see that this 23 is representing binary, and here we have the decimal. But on Mars, actually, you would put like S0. So because it's more readable, it's more memorable. So the same thing goes with this. So register 22, which is RS, is going to this position. And if you look at these, this is going to be basically 16 plus 4, that is 20, and then plus 2, that is 22. So you see that this is 22 and it's converted. And the last one, we have 13, and 13 is going to the middle location. And here, if you look at that, it's going to be this one, the blue one. And that is basically 8 plus 4, which is 12, plus 1, which is 13. So it's very, it's a bit like time consuming to actually convert these, but that is the exact process of assembly. And that is the only way that the CPU can basically understand all these instructions and know how to run these instructions.